In the second part of this series, we're going to be looking at using these sign charts not to determine where a function is positive, negative, undefined, and equal to zero, but to solve inequalities. Now, before we do, I just want to highlight that if you're looking to practice more questions, chapter 10.4, questions 1 through 26 are great questions to practice in terms of where is a function positive, negative, undefined, and equal to zero. Now, what we're going to do is we're going to take our split point technique and we're going to change it slightly. Now, when working with inequalities, the challenge is we cannot multiply because we do not know if the term is negative or positive. So because we can't multiply, what we're going to do is we're going to use addition or subtraction. So for solving these inequalities, we typically rely on addition or subtraction to move everything to one side. Okay. Then once everything's on one side, the rest of the steps you see are the exact same as what we just did before. The exact same. Create one common denominator, factor the numerator and denominator, identify your split points, create a sign chart, indicate which split points are zeros and which are undefined, determine the sign of the intervals, and write out your answer using set builder or interval notation. So if we take a look at these two inequalities, we've got x over x minus 3 is greater than 5. Now, x over x minus 3 is greater than 5. This implies that x over x minus 3 minus 5 is greater than 0. Okay? This is step 1. Now, step 2, what we're going to do is a common denominator. This implies that x minus 3 minus 5 times x minus 3 over x minus 3 is greater than 0, which implies that x minus 5x plus 15 all over x minus 3 is greater than 0. Now, here, this implies that minus 5x, or sorry, minus 4x plus 15 over x minus 3 is greater than 0. Some people would say this is factored. This here is step 2, common denominator. I'm now looking into step 3. Some people would say that this is factored, but I would say not quite. I am not quite done factoring this. I don't like this minus 4 plus 15. I prefer to factor this to give me minus 4 x minus 15 over 4. And I'm just factoring out that minus 4 here. Over x minus 3 is greater than 0. The reason I like to factor this out is because now it's easy to determine what my split points are. Okay? My split points, which is step 4, my split points are x equaling 15 over 4 and x equaling 3, which to help figure out which one's bigger, this is 12 over 4. So 3 is less than 15 over 4. Okay. Now here, at 15 over 4, I equal 0. At 3, I do not exist. So when I create my sign chart, I have 3 and I have 15 over 4. Here, I don't exist. Here, I equal 0. Now, I'm going to write out every factor that's involved. Minus 4, x minus 15 over 4, and x minus 3. So those are all of my factors. Now, to complete the sign chart, I'm going to look at what happens to each factor on the far right side. I'm going to throw in a massive number, say 80. Well, minus 4, when you plug in 80, is always going to be minus 4, so it's negative. Now, minus 4, if I plug in a massive negative number, like minus 1,000, it's still going to be minus 4, it's negative. So it's negative everywhere. But x minus 15 over 4, if I plug in 1,000, that's going to be positive. If I plug in minus 1,000, it's going to be negative, meaning I change sign. Now this function, x minus 15 over 4, only can change sign at one spot, and that is 15 over 4. So I know that everything above 15 over 4 is positive, everything below it is negative. Similar for x minus 3. Plug in a massive number like 1,000, we get positive. Plug in a massive negative number like negative 1,000, we get a negative. It is negative before the split and positive after. Well, the split is 3, so positive, positive, negative. Now that I've completed the row for each factor, I simply just multiply my signs. Negative, because there's 3. Positive, because there's 2. Negative, because there's 1. And I know that at 3, it does not exist. At 15 over 4, it's 0. Now I look back to my equality. Negative means less than. Positive means greater than. And I'm just going to write out for clarity what these domains are. Minus infinity to 3, 3 to 15 over 4, and 15 over 4 to infinity. Now here I'm looking, where am I greater? Well, my function is greater for 3 to 15 over 4. Thus, the inequality is satisfied for x in the interval 3 to 15, 4. Now we look at our second example. Here I've got x over x squared minus 4 less than or equal to 1 over x minus 2. And here in this second example, I can bring it either side. I'm going to bring it over to this side. So this implies that x minus x squared minus 4 minus 1 over x minus 2 is less than or equal to 0. To make my analysis a little bit easier, I'll factor the bottom, x minus 2, x plus 2, minus 1 over x minus 2 is less than or equal to 0. And here, I need to make the denominators match to create a common denominator. So x plus 2 over x plus 2. Well, this implies that x minus x plus 2 over x minus 2, x plus 2 is less than 0, which implies that minus 2 over x minus 2, x plus 2 is less than or equal to 0. This is going all the way to step 3. Now, step 4, what are my split points? Split points are x equaling minus 2 and x equaling 2. Note, x does not equal, or note, the inequality is not defined for x equaling 2 or minus 2 because it's on the denominator. So when I create my sign chart, I'm going to create it about the split points. And there's 2 split points, minus 2 and 2. And I'm going to tell the world right away, no, at 2 and minus 2, it doesn't work. But now I'm going to take this expression, I'm going to split it. I got minus 2, I got x plus 2, and I got x minus 2. Okay. Well, now from here, I've got minus 2. Now, minus 2 is negative everywhere. What about x plus 2? Well, for a big number, it's positive. For a really big negative number, it's negative. And it changes at negative 2. So I'm positive above and negative below. Similar for x minus 2, plug in a big number, it's positive. Plug in a big negative number, it's negative. And it changes at 2. So it's negative below and positive above. Multiplying the signs together, we get negative, positive, negative. And again, we're not defined on the splits. So this is going to be minus infinity to minus 2. This is 2 minus 2 to 2. And this is 2 to infinity. Okay. Now, if we look at my last expression, it wanted less than or equal to 0. Well, this is true in these two regions. We don't include minus 2 or 2 because it's not defined there. So the inequality is satisfied for x in the interval minus infinity to minus 2, union with 2 to infinity. And we have our solution. Okay. I'm going to be leaving this last example as an exercise for you guys to work through. I think it's a nice exercise. It's a nice application. And in chapter 10.4, there's some more questions you can work through to help you with these sign charts and working through the sign charts. I would really encourage working through these questions, chapter 10.4, 1 through 26, as they will be most beneficial in terms of determining where a function is positive, negative, undefined, or equal to 0.